So continuing on, let's talk about the incremental encoder counter applications. So an incremental encoders are used to track motion. They provide a specific number of equally spaced pulses per revolution or per inch or millimeter of linear motion. Incremental encoder output pulses each time and only when the shaft is turned. The encoder just interrupts the light as the encoder shaft is rotated to produce the square wave output waveform. For cutting object to specified length, the object is to advance for a specified distance and measure by encoder pulse to determine the correct length for cutting. So once again, this is getting into the realm of what we do in our CNC part of our course, but you can see some of the things that would be associated with a programmable controller. Counter program used for length measurements, and this is what we would have here for programming that. Then for combining counter and timer functions, we can be having something like an automatic stacking program. So you go to a stack and then you count so many that you put on each stack. And so you need to have a counter and then you have a time on delay to get this to be done correctly. So we can see how this will be a useful function in an assembly line. Here we have a motor lockout program. So we can see a combination of things that we've already talked about, putting that together for a practical application. Next, we have a product flow rate program. This is what that would look like. So you can feel free to take a look at that in more detail. Here we have a timer driving a counter to produce an extremely long time delay period. And so we talked about this before. If we wanted to be having a long time that we're trying to count, if we have a counter that can manage that, then a single counter, then we know how to handle that. If not, we'd have to start to daisy chain a couple together. And finally, just to finish up, we'll just have this last chart, is thinking about high-speed counters. The maximum counting frequency of a PLC is limited by the scan time of the processor. When the frequency of input signal is higher than that of the scan time, it is necessary to utilize a high-speed counter, HSC, to avoid errors. The HSC instruction may be embedded in the CPU or fixed hardware or a separate module.